This session is related to electromagnetic spectrum or electromagnetic waves. What is the concept of electromagnetic wave? The wave which can pass through a vacuum. They can travel through a vacuum. They don't need or require a medium. We call that as electromagnetic waves. And all the electromagnetic waves, the group of all the electromagnetic wave is refers to electromagnetic spectrum. So you have to learn this electromagnetic spectrum, not the frequency and the wavelength, but the order. The first, the names, what are the electromagnetic waves? Electromagnetic wave means a wave which can travel through vacuum. All of them have a capability to travel through vacuum, which is radio wave, can travel through vacuum, microwave can travel through vacuum, infrared can travel through vacuum, visible can travel through vacuum. Why we call this as a visible? Because this is the only ray, or this is the only wave which we can see. Our eye is sensitive. The rest, all the other waves we are not able to see. That's why we call them as visible rays. So it include radio waves. Order is also important. You have to learn the order. It is radio wave, microwave, infrared, visible, ultraviolet, X-ray and gamma. And it can be other way around. You can start with the gamma, then you can say X-ray, then ultraviolet, then 4 is visible, 5th is infra, 6 is micro, and 7th will be radio. But how the order is different, like from left to right or right to left, how they're different, like how the radio waves are different from gamma. Basically, radio waves have a longer wavelength. Longer wavelength means they have greater spacing between the successive crest. But when we move towards the gamma, the wavelength decreases, as the wavelength is the distance between the two successive crests. So for radio wave, they have a greater difference between the two successive crests, or greater distance. And for gamma, they have a shorter distance. So that's why the radio wave is having a longer wavelength. Wavelength is denoted by a Greek alphabet lambda, and where gamma is having a shorter wavelength. Shorter wavelength is smaller spacing between the two waves. But gamma is having the highest frequency, like it is having more vibration per second, and radio is having a few vibrations per second. So the one which is having, what is the characteristic of the radio one? Radio wave is having a longer wavelength and a short frequency. Whereas gamma is having the highest frequency and the shortest wavelength. And rest, like comparative is there. So when we compare, radio wave is having a longer wavelength than micro, micro is having a longer wavelength than infra, infra is having a longer wavelength than infra is having a longer wavelength than visible, and visible is having a longer wavelength than ultraviolet. Ultraviolet is having a longer wavelength than X-ray, and X-ray is having a longer wavelength than gamma. So this is the order of the wavelength and the order of the frequency. Like the one which is having the highest frequency, that is gamma. So gamma is having the highest frequency, whereas radio is having the shortest frequency. And gamma frequency is higher than X-ray, X-ray frequency is higher than ultraviolet, Ultraviolet is higher than visible, visible is higher than infra, infra is higher than micro, and micro is higher than radio. So the properties, what are the characteristic or the properties of all these electromagnetic waves? They are all transverse. What is the meaning of all transverse? Means the vibration is perpendicular or 90 degree to the direction of the wave. The vibration is up and down where the wave is traveling either towards right or left. That's why we call transverse. So all these waves are transverse. They all travel with the same speed in vacuum, which is 3 into 10 power 8. And they all can travel through vacuum. They can pass through vacuum, does not require a medium. Then the application of these electromagnetic waves or uses of electromagnetic wave, radio waves, where we use radio waves, they have a lower frequency and highest wavelength. So they are used in mainly radio and television communication. So example, because it is having a longer wavelength, so it need a large antenna. Radio wave is having a longer wavelength, several meter long wavelength is there, so they need large antenna to detect. That is why, example, if you want to use your mobile as a radio, what you have to do, it always give a message when you try to open the application for a radio. It give you a message that connect a headphone. So the moment when you connect the headphones, actually the headphones are acting like an antenna. So when you connect a headphone, now because of these headphones, the radio waves can be detected as it is acting like an antenna, and then your mobile is try responding to the radio waves and give you the output result. So normally we use radio waves for radio communication or television communication. What are microwaves? The microwaves are used for satellite communication. Because what happened, the microwaves are shorter in wavelength compared to that of radio waves. If this is the earth atmosphere, the microwaves are, because compared to, if there is a radio wave, like example a black waves are representing radio wave, radio wave is having a longer wavelength, so when radio waves strike the earth atmosphere, it returned back to the earth. But microwave, the blue lines are representing the microwaves, they are relatively shorter in the wavelength. So as they're shorter in wavelength, they're able to pass through the earth atmosphere. So if we want to use the microwaves for communication, we need a satellite. So a satellite detect these microwaves and it resend back to the earth, and we can use for communication. So mobile communication, like example, if you are at position A and you want to communicate to a person at position B, so your mobile is actually a radio wave, is a microwave source and the detector. So when you make a call, it produces microwaves which travel through and send back to the earth by a satellite and connect to a person at B. Why radio waves cannot be used for mobile communication? Because what happens if you try to use radio waves for mobile communication, they cannot cover, because if you use a radio wave, they can cover only this distance, like going and coming back. But using a satellite, like example, if I want to communicate to a person at position C, so how a satellite communication can be done? So when we make a call, we are at position A. So we make a call, a satellite receives that call, and then it's sent to this another satellite which locate the position of a person at C, and you are able to communicate to a person at position C. So using this microwaves, you are able to communicate to a longer distance by the help of satellites. So microwaves are used for satellite communication. whereas radio waves are used for land communication. If you want to communicate someone by using a wave on the land, like you are on the land and another person at the land, and you want to directly send the wave, we use microwave. But for we use radio wave. But for satellite communication, we use microwave. This is what happened, like a satellite television, you are able to see different channels on your television. How it happened? Basically, like this is a ground station. So your example in continent Asia, and you are in continent Asia and you want to see a channel which is aired from Europe. So how you are able to see or detect? So the ground station for that channel, they're sending the wave to a transponder or a satellite, and this satellite, it record and it resend that signal. And on earth, when you are at even at a different continent, you are receiving those signal and you are able to see the channel on your television. So this is how, like, from one continent to another, we are able to communicate by using these microwaves. Is it clear? Then infrared radiation or heat radiation, we use these infrared radiation or heat radiation in a remote control. So maybe you have seen when you are looking at the remote control, like here, this is a remote control, and the front side, you will see a transparent object. What is this transparent object? So this transparent object, what it produces when you press a button on your remote control, so what it produces infrared radiation, IR radiation. So when it produces infrared radiation, these infrared radiations detected by, like example, if it is a television remote control, then it will change the channel, or it can increase the volume or decrease the volume depending on what button you press. So the moment you press the button, it produces infrared radiation, and these infrared radiation, when it pass through the detector, like example, you can have a remote for an air condition. There are many devices which are operated by a remote. So it can be a television. So using the infrared radiation, we are able to transfer information from one place to another. So most common is that remote controls, when we press the button, it's producing an infrared radiation which is detected by a device, and it will uh, do the application run on the device based on what button we press. Like example, if it's a TV remote control, if we want to increase the volume, we are pressing a different button. If we want to decrease the volume, we press a different button. So they all produce, like when we are pressing different buttons, it is producing different pattern of infrared radiation, which we are not able to see this infrared radiation, but we are able to communicate by using this infrared radiation. It is also used in security. Like example, this is a source. In case, for example, infrared detectors are there or heat detectors are there, a human body, as there's a continuous chemical reaction in the human body, it is producing heat. So if a person is there at position A, so this detector can record this heat radiation, and if it can record this heat radiation, so the alarm will ring that if there is a person at specific location. So we can use for intruder alarms which detect the heat radiation from the body, or we can also use for a television controllers. Is it clear? How infrared radiations are used? Then the visible light, the light we can use for communication, the visible light will undergo total internal reflection, and like example, we are able to communicate or transfer information from one place to another. So one side opening is there, the light will pass through and it will undergo total internal reflection. As you can see, the bundle of optical fiber, and this is also used for communication or in transferring information from one place to another. We can also use this visible light to observe the thing. Like if you want to observe the object or the thing, we can also use this visible light. The ultraviolet radiation or UV radiation, they they can use to sterilize the food, or it can also be used to kill bacteria or to provide vitamin D. So infrared, ultraviolet radiations are there. Example, this is a meat which is exposed to UV radiation. So when it is exposed to UV radiation or ultraviolet radiation, it will not allow the bacteria to grow. So it will sterilize this meat. So it will keep for fresh for a longer period of a time. Then X-rays are used in medical imaging, like to identify the crack in the bone. We can use X-ray to identify the metals, like if there's a crack in the metal, we can also use X-ray. Or security, airport security, like they check your luggage. When you place your luggage on the conveyor belt, it take your luggage into a closed compartment, closed area, which in which they pass X-ray. So when they're passing this X-ray, so they're able to identify that any metallic object is there. How they're able to identify? Because X-ray cannot pass through the metal or the bones. So if any metallic object is there, they're able to create an image of that metallic object. And the last one is a gamma. It is used for treatment of the tumor or the cancer. Like example, if a person is having a tumor or the cancer, gamma is having the highest frequency or most energy. So the person is, his body is exposed to these gamma radiation. So when it is exposed to gamma radiation, these gamma radiation can kill the cancer cell or can be used for treatment of the cancer. Is it clear, this point? The uses of these electromagnetic radiation? Any doubt? Yeah, gamma are too strong. Gamma is having the great, they're able to pass through the human body, and they can cause, they can kill the cells. So even if a person is, if a healthy person is exposed to gamma radiation, he might develop a cancer. So that's a very sophisticated technique with just focusing on the region or the part where there is a tumor, is that is exposed to gamma. So gamma is having, as I mentioned in the beginning, that the gamma is having the highest frequency or the most energy and the most dangerous, because too much energy is there, our body is not able to tolerate or bear that extra too much energy. That's why these gamma radiations are harmful if a person is exposed to these gamma radiation for a longer period of a time. So radio waves used for radio communication, microwaves are used for mobile communication or through satellite, infrared is for remote controls, visible light to see the object, ultraviolet to kill bacteria or to produce vitamin D, X-rays to identify the blockage, to identify the crack in the bones of the or the metal, or can be used at airports. Gamma is having the highest frequency. It is used as treatment of the cancer. We call it a radiotherapy. Then what is the meaning of dispersion of the light? Dispersion of the light means when the white light spread into colors, we call that as dispersion. Basically, white light is a combination of 7 colors, which is red, orange, yellow, green, blue, indigo, and violet. And when the white light passes through the glass, it spread and violet bends the most. The violet color bends the most and the red color bends the least. What is the reason why the violet bends the most and the red bends the least? You have the violet, indigo, blue, green, yellow, orange, and red. The violet is having the highest frequency. The one which is having the highest frequency will have a greater change in speed. So that's why the violet bends the most and red bends the least. So whenever a white light passing through a glass is spread into 7 colors, we call that as dispersion. But if we have only one color light, then we say that as a monochromatic light. But if it is 7 color, we call that as a white light. Example, this is a glass and a white light. When I say a white light, it means it is a combination of 7 colors. So white light include violet, indigo, blue, green, yellow, orange, and red. But when these 7 color passes, what we observe, because they're in the glass, they travel at different speed, so they will bend toward the normal. Imaginary line which is perpendicular to the surface, that is normal. So they will bend towards the normal. Violet bends the most and the red will bend the, it will bend, but it will bend the least. And this spreading of colors, what we call that as dispersion. Is it clear, the concept of dispersion? Simply it refers to spreading of the light into its component or fragment. That's how you're able to see a rainbow, and rainbow is only visible if you have like a moisture in the air and there is a sunlight. If without sunlight you are not able to observe rainbow. What happened, how you are able to see the rainbow or observe the rainbow? When the light from the sun is also called a white light. Why we call that as a white light? Because it is a combination of 7 colors. So example, this is a raindrop and the light which is coming from the sun is a white light. So when this white light enter the raindrop, because moving from air to glass, it will bend, and in this case the violet will bend the most and the violet bends the most and red bends the least. But both will bend. And as a result, because the color spread, the violet and the red color spread and all others are there, indigo, blue, green, yellow, orange, and red are in between. So as a result, what we'll see, as you can see in this image, the light which is coming from the sun is violet bends the most and the red bends the least. And when they strike the raindrop, They will come out, but as they spread out into colors like fragments, so we'll see 7 colors or we'll see a rainbow. Is it clear? The formation of the rainbow? Any doubt till this point?